Albert Einstein was right when he predicted that we would never be able to see the edge of the universe. The James Webb Space Telescope, JWST, has now observed a void in the extremely early universe that could confirm this prediction. But what are we really seeing here? Is it really a void, and could it be the beginning of the universe? Scientists may have discovered a shocking fact. A strange void at the beginning of time may now confirm a remarkable prediction by Albert Einstein. Imagine how 100 years ago, scientists slowly began to look beyond the edges of the Milky Way. What they saw astonished them. At first, it was just hazy nebulae, but then it became clear that these nebulae were other galaxies. First, the small and large Magellanic clouds became visible, then the Andromeda Galaxy, and finally the shock. Scientists realized how many more galaxies there were. Based on these findings, ideas such as the evolution of galaxies and the infinity of the universe were born. Then Edwin Hubble observed that distant galaxies were moving away from us, and the idea of expansion was born. Shortly afterward, the Belgian Georges Lemaitre came up with the Big Bang theory. This all took place slightly after the time when Albert Einstein presented his theories of relativity. Many of the researchers' basic theoretical predictions, which had been made within the 1910s and 1920s, had been confirmed with the aid of new discoveries. However, Einstein was unsure during his life whether the universe truly had a beginning and an end. Although he fundamentally accepted the Big Bang theory, Einstein was always certain about another interesting question. Although the universe did have a beginning and an end, he was convinced that we might never be capable of seeing this beginning and end, regardless of how good our telescopes were. How did Einstein come up with this seemingly crazy idea, and what does it have to do with the void found by the James Webb Space Telescope? Einstein was truly one of the most critical physicists of the 20th century, and he made many predictions that are still cornerstones of cutting-edge technology today. One profound insight was the aforementioned prediction that we could never directly observe the absolute beginning of the universe. Einstein gave two exciting reasons for this. Firstly, the concept of the Big Bang and other theories based on it postulated that there was no light for hundreds of thousands of years immediately after the Big Bang. Today, scientists call this epoch the Dark Age. So how could we see a point in time, or an event with telescopes, when there was no light? There are even a few interesting answers to this question nowadays, including radio telescopes. These do not see but rather listen. However, researchers are quite certain that the Big Bang was not a loud explosion but occurred in complete silence. Essentially, the space in which an audible explosion could have taken place did not even exist at the time of the Big Bang. Space itself only came into being with the Big Bang and was formed as a consequence of this event. Radio telescopes detect waves that are typically from the audible sound spectrum. Space hardly conducts any sound, and only a few other waves penetrate the interstellar medium, which can be made audible using modern technology. We would therefore not really be capable of hearing the presumably silent beginning of the universe. We found the cosmic background radiation back in 1960s and have since mapped it very well. This radiation is considered to be an aftereffect of the Big Bang, and much evidence for the Big Bang has been derived from it. However, the microwave background has never led us directly to the Big Bang, so here too we seemingly have no way of detecting or proving the absolute beginning. But Einstein also had another reason for believing that we could never see all the way to the start or the edge of the universe. He believed that the beginning would move further and further away from us due to the growth and expansion of the universe, and would therefore always remain out of our range of vision, so to speak. Albert Einstein also sometimes believed in the curvature of all space. This means that the starting point could also be behind a sort of horizon that would forever obscure our view. Now imagine again that this was at a time when the best telescopes were only capable of blurring neighboring galaxies. Today we know of the existence of hundreds of millions of galaxies in a universe teeming with galaxies, expanding so much and getting bigger and bigger. It may be really difficult to peer very far at all, but that is not true. Although our cosmos is so rich, the areas between galaxies and galaxy clusters are so vast that we can now see 13.6 billion years away with our telescopes. That will be very close to the Big Bang. And with the James Webb Space Telescope, we're already pretty damn close. I'm sure you've heard that the JWST has discovered an exceptionally large number of very, very old galaxies that now even call the Big Bang into question. But did you also know that the JWST has located an odd void that could verify Albert Einstein's prediction of the non-observability of the absolute beginning? Absolute voids are mysterious areas inside the universe. They're so empty, they virtually contradict the principle of relativity. But how can it be that they confirm Einstein's concept about the invisibility of the start? This is initially explained by the fact that the vacancy was thought to be a representation of the Dark Ages, in which there was not much, at least no stars and no galaxies. Some researchers believe that the discovery had at least confirmed the existence of this epoch. But then came the shock. The darkness turned out to be an exceedingly distant void. We also know of nearer and more recent voids. These voids already pose puzzles, but in the extremely early universe, voids are once again scientific impossibilities. They do not fit into the idea of the homogeneity of the universe, which is directly linked to the concept of the Big Bang or expansion. Voids are too large and too unusual. They have an inhomogeneous nature and contradict some of the principles of our cosmology. A void does not directly confirm Albert Einstein's prediction, but the Webb telescope appears to confirm the view of the great scientist in another way. The telescope has thus far detected no trace of a beginning or an early stage of a universe. The images of the allegedly extremely early universe only show structures and galaxies that do not appear very different from those we know from a universe we can study more closely. The question now arises as to whether a mysterious void could have been the beginning of the universe. We can't completely rule this out because, in the end, we never really know what voids actually are. Today, we also have to admit that we do not understand how the universe truly began. Voids are probably empty, but we don't know that for sure either. It's possible that they contain some kind of matter that we don't know about. Imagine dark galaxies. Voids are sometimes interpreted as some kind of parallel worlds, and some scientists see them as scar tissue from the collision of universes in the multiverse. Other wild theories claim that aliens darken the galaxies in a void to harvest energy. So you can already see that these mysterious voids challenge our scientists and lead to the wildest theories. Of course, it could be that our universe was created in a massive void. The mere fact that we cannot prove otherwise reinforces such an idea. That leaves the question of how our universe was created. We've already talked about the nothingness from which the universe is said to have emerged. If that was truly the starting point, how could we observe it? After all, it was nothing, and therefore not detectable for us. A singularity is a point at which all forces are so condensed that our concepts of value and size break down, or everything that exists is concentrated into this one point. The point consisted of a fluctuation of possibilities that existed in a state of complete equilibrium. A previously unknown event is said to have disturbed the standstill at one point, and creation started from this tiny point. Everything that we know and can see today came into being. This means, no less, that the information for you and me, all life on Earth, every megastar, and every exoplanet was contained in this tiny dot of nothing. The question of how an infinitesimally small dot of nothing can contain everything is one of the great mysteries of science, and is currently unclear whether we will ever be able to solve this puzzle. We find these mysterious singularities in another place in the universe, specifically at the center of black holes. These, in turn, are located at the center of pretty much every known galaxy. Black holes are what remain when stars of a certain size explode. At least that's what scientists believe. No one has ever been to the center of a black hole, and as we've discussed, we have hardly any way of seeing the absolute starting point of the universe, if it even existed at all. Everything is based on calculations that made sense until the James Webb Space Telescope discovered something very different from what our theories had postulated. The Webb telescope shows that the universe may be much older than we assumed, or that its nature is quite different from what all our calculations expected. Black holes are also one of the great mysteries.